Hi students, this is Alex here. In this video, we are going to find the solutions of standard types of first order partial differential equation. The standard type which we are going to consider here is f of p comma q equal to 0. Now coming to the question, we have solved p square plus q square is equal to n times pq, where n is a constant. So this question is in terms of p and q. So we know this is of the form f of p comma q equal to 0. So we are going to assume the solution. So assume solution as z equal to ax plus by plus c. When we differentiate partially with respect to x, it is dou z by dou x, which is a, and dou z by dou y partial differentiation with respect to y is b. This is actually named as p and q. Let's take this as the first expression and we are going to substitute p as a and q as b. So substituting in 1, p square will become a square and q square becomes b square n a b. And let's rearrange this quadratic expression. A square plus b square minus nab. We need to find the value of b. So let's rearrange the quadratic expression in terms of b. So b square minus nab and plus a square equal to 0. To find the value of b, we are going to use the formula, quadratic expression formula. That is b equal to, by formula, the general formula is x is equal to minus b plus or minus root of b square minus 4ac whole divided by 2a. So here the value of a is 1 from this and value of b is minus na and this is the value of c. So if I substitute minus b, that becomes na plus or minus root of b square will become minus na whole square is n square a square minus 4a, a is 1, c is a square whole divided by 2a. So 2 into 1. So from this b is na plus or minus, and we can take a square common, that comes outside as a, then we left with root of n square minus 4 whole divided by 2, and from this entire term we can take a common, so we left with a by 2 and in the numerator it is n plus or minus root of n square minus 4. This value of b we are going to substitute in this place, we get the complete solution. So the complete solution is z equal to ax plus b. b is a by 2 into n plus or minus root of n square minus 4 into y plus c. Now let's take this as the second expression. Now differentiating this second expression partially with respect to c, we get left hand side 0 and right hand side everything is constant except c, and c derivative is 1. 0 equal to 1, so which is not possible, so which is absurd. Therefore there is no singular integral. When there is no singular integral, we take the c as the function of the constant a. So we get z equal to ax plus a by 2 into n plus or minus root n square minus 4 into y plus f of a. Let's keep this as a third expression and we are going to differentiate this third expression partially with respect to the constant a. So this will become 0, here x is constant and here y is constant, and here a is a variable. So a derivative is 1. So we have 1 and denominator 2 as it is, and all these n terms are constant, that is n plus or minus root n square minus 4 is fully constant, and the last term is f dash of a. Let's keep this as the fourth expression. From these two, that is from 3 and 4, eliminating a, we get the general solution.